Well, in this recording, I mean, we are going to draw the demand curve. We are going to draw the demand curve for perfect substitutes. Okay, we are going to draw the demand curve for perfect substitutes. So you have a utility function, say, which is equal to x plus y. Now in the earlier recording we have derived the demand curve for the perfect substitutes for this kind of utility function. Well, and we know this. Okay, let's even draw the indifference curve and the demand curve for these cases. So you have this, and well, you also know this, that that demand curve is IC is going to be like this for this utility function. Okay, so this is x and this is y. Okay, so what have we said in that recording? When P1 is less than P2, the demand for x and y are m by P1 and 0. Okay, so there is none of y which is being consumed and all of x is consumed. So this is your m by P1. Well, if P1 is greater than P2, the demand for x and y, I should rather put a star here, okay, that is x and y, and this is this is 0 and m by P2. Okay, so none of x and all of y, so this point is m by P2. And if P1 is equal to P2, the demand for x and y is, I mean, of course, it could be any combination, that is 0 to m by P1 or 0 to m by P2. Clear? So it means that when P1 is equal to P2, so you can consume anywhere on this line, on this indifference curve, anywhere. Okay, so 0 to m by P1 would mean that suppose if you take up 0 here, okay, it means that you're not buying anything of x and you're buying all of y. Okay, 2 m by P1 means you can buy all of x and none of y. 2 is taking this word 2 is taking care of all the points on this indifference curve. Okay, so x could be anywhere here also, that 2. Similarly for y could be anywhere because of this 2. So this is the case. Now, how do you draw the demand curve basically? So, well, this was an indifference curve. The demand curve is gonna be like this. Clear? And this is the quantity demanded of x. Okay, and this is the price. Clear? So this is the quantity demanded of x and this is the price. So when P1 is greater than P2, okay, now this is the point, say this is the point where P1 is equal to P2. Okay, and all of these points, this point is where P1 is greater than P2. So when P1 is greater than P2, then how much of x is bought? 0. Okay, so all of this is actually going to be the demand curve. Let me put in another color to it. Okay, say, yeah. Okay, and if P1 is equal to P2, clear? Now P1 is equal to P2, then he can consume anything between 0 to m by P1, clear? That is, let me again, just wait. So it is like this. So anything between, I'll ask you that what exactly is going to be this x, and the region which is below this, okay, now this region is actually your P1 less than P2, okay. So in this region, the demand curve will have the natural shape, okay. In this region, the demand curve is going to have the natural shape, clear? So, and what is this point? Okay, now what is this point? In case if you have a look at this point, okay, I want to know what is this point. So this point is actually your m by P1 is equal to m by P2. Now this is this point, clear? So, and in this range, of course, your P1 is equal to P2. So you understood that how is the demand curve? This blue line is the demand curve for X. So this is the drawing of the demand curve of the perfect substitutes for this kind of a utility function. Thanks.